That's my end. All right, so this is a very classic use lead code question and classical user code question as well. So if you open the user code questions, all right. This question has a little similarity to the lonely photo questions here. Because as you can see, if you check the solutions here, this is a simulation, all right? So this is absolutely a simulation algorithm here. And you could also optimize this solution by OM. So which means you have to trim it, all right? So which means you have to remove um, the the redundant data here. So this is a little trimming here. Even though you see this is a double loop here, absolutely this is not because you can just well shorten the distance, right? So right here, so basically I'm going to do from the very naive solution. This is naive, right? Naive solution is basically um you just simulate it, right? So integer range here. This is a -2 here, and a 4j in range. So these the I plus one, the I plus one, and n here, and a 4k in range. This is j plus one and n, right? Okay. So what we really want to do is simply just to have the total sum here, right? So this is s equals this one plus this one and a plus this one, right? Okay. And this is a K, this is J, and this is L, this is I, right? Okay. If uh, if this one is a zero, right? So we basically add it to the inner. So right here, I'm going to have inner equals, this one is going to be a list here. And right here, a conditional statement, if S is a zero, that means the sum is a zero. So we have the rest period append, we append inner in. And where is the rest? Rest is basically it's a 2D array here, right? Okay. And then we also need to do what? We also need to append the data to inner, right? So inner period append. So you're going to append this one, and then you also need to append the rest, right? Okay. So all of these are just the repeating stuff, right? Okay. And next things you need to check. So if it is in, right? So if item in inner, if item, if inner in rest, right? Okay. Or not in rest. So we have to define to check if it's not in the adult here. If that is true, we add in. Otherwise, we do not. So by doing that, usually, all right, so this is going to be okay. So to pass the, uh, some uh, some cases, I guess probably is going to be almost a full score. No, we have this one here. So this is we have the redundant data here, right? So I guess the problem, yes, we need to sort, right? So inner period sort. We also need to sort the inner um, array. So therefore, it can check, okay, if it's identical stuff. So this is almost a full score here. Good. But however, USICO wants you to solve the problem with full score, right? Okay. So now we need to think how do we make all of these a bit faster, right? Okay. So the first thought is so since we have the data here, so we have the, for instance, maybe 1, 2, 3, 4, 5, 6, right? Okay. So no matter how we need to one outer loop to anchor this data, right? And but for the inner part, we can use two pointers, right? So one pointers at left part, another pointer at the right hand part, right? So for that, we define the left, okay, equals, I'll just use L. L is basically I plus one because one next to it, right? And R is basically n minus one, right? Because it always goes from the negative direction. And then we can set up the while loop here. So while L less than R. That is true, right? So we're going to shorten the distance here. And now another important concept is, okay, we need to define a formula here. So x plus y plus z. So it is supposed to be equal to 0. If that is true, suppose x is unknown, right? So we move everything to the other side. So we get y plus z, and we could also put a 0 here, right? Okay. So, and where x equals nums of I, right? Okay. So if that is true, we just need to check the condition of these two data, right? Okay. So, and that is if we can also have something like a CS, the current S equals nums of something plus nums of something. So this one's going to be K, and this one's going to be J, and right here. So now we need to define something, right? So if CS is equivalent to X, right? Or this X is basically nums of I, right? If that is true, that simply means it is the equation is good. If the equation is good, so definitely we need to add it into the club, right? So we just do the simple trick here, right? Append, and this one's going to be nums of I here. So for these, I'll just copy this, paste and paste, and right here you put J here, and this is a K here, right? Okay. And do we want to sort it? Yes, we also want to sort it, right? But the priority is, the prerequisite is we still need to sort the original array, right? Otherwise, this problem cannot be solved, right? Okay. So this will takes basically O and log and time complexity, right? Okay. This will do the same. All right, okay. So now for this part, we also need to push the left and the right pointer, right? So this is a left plus plus, right? And this is a plus equals one, and this R minus equals one. And we also have L if what? L if CS maybe if that is bigger than X. So what does that mean? That simply means CS minus X is bigger than 0. So or you can use other way, so which is x um, minus CS is less than 0, right? Okay, you can use it both way to think. If you are using the first logic here, that means that means CS is too big. If CS is too big, because minus 0 is minus X is bigger than 0, right? We need to lower the value of the CS. That simply means we need to push the right pointer to the left hand side, right? It's minus 1. And then else is basically L plus 1, right? Okay. And by doing that, so we're able to possibly solve this problem, right? Okay. We have the inner here, right? Rest is here. Inner, I guess we didn't define the inner. So inner is going to be something here, right? Okay. Do we define the inner here? Yes, I think so. Because every times if that is true, we add it in. Otherwise, we need to keep updating it, right? Okay. And I guess we got everything here, right? Okay. And then, so let's maybe compile and run this code a little bit to see what is happening here. Oh, we have some little stuff here. Nums of J. Oh, we do not have J. This is L, and this is going to be R. So this one is going to be L. This one is going to be R. Now let's compile this one more time. We don't know X, okay? Absolutely, we don't know X. It's because I didn't define it, right? Okay. So for this part, okay, this mistake is a good mistake because you are still using your logic to handle the program, right? Okay. So later on, you just need to replace the stuff. So now, as we can see, so we also have some little stuff here. The output is empty here, so except is this. So I guess there's something wrong here. It is, we probably need to have this one is a plus this one, maybe it's equivalent to 0. So maybe let's see this. So if we do that, because I guess the way we define that is still this. Now let's see what is going on here. Sort. Do we need to sort? We sort this one. I think. Do we? I think maybe we still need to check. So for if items, if item not in res, we res period append in array. I guess we still need to have these ones. And let's round these a little bit. Uh, maybe okay. We have item. No, this is an inner, right? Okay. This is inner, and that. Let's give it a go. Okay. So for the optimization process, so you probably need to practice a bit more. So it passed this step here. Oh, it seems like wait a sec. So it that simply means we have too many data here. So we have negative this one. Oh, wait a sec. Oh, we should have more actually. So this one is these, this one's that, and this one -1 and that. This one, yes, it doesn't pass through these. So for that, this is n -1. And this is this, and this is the result. So that simply means I have, okay, this one, this one, this one, this one, this one, this one, this one here, this one here, this one here. Now let's check it out. So every time I have equivalent, I think every time I have equivalent, do I, well, I think I still need to push it forward, right? Still need to push it forward. And L plus one and this one. If CS bigger than that, we do these. And CS is that and else. Let's see if I press around. I think maybe 3 green lights here. Yes, there's a 3 green lights here. And 1, 2, 3, good. And this one 0, 0, there's nothing. Now the problem is for the larger step here, so this one, okay, sort n -2, and L is I plus 1 always, and R is n -1 always, and what if they have the same data? What if they have the same value here? So therefore, uh, would they compile the closer? No, I don't think. So this one, I think it is going to be less than. It is going to be less than, definitely. So if it's less than that, I declare a list because in the current one, I should have more, I guess. So the inners must be declared inside. So, and a CS is going to be nums L plus nums of R. And if they're equivalent, L, R, okay, append. And do I sort this one? Yes, I do think I need to sort. If here not in res, this one will be added in. And L push forward and R push back. And else if CS minus X, CS minus X is bigger than 0. If it's bigger than 0, that simply means I need to push it to the left directions. Let's see that. Okay, so if they're the same, what if I modify, okay, what if I modify the direction? So it's a plus, minus, sorry, let's give it a go. Maybe there's something wrong with the direction stuff, but I don't quite, it gets more, but uh, it gets more. Oh, I think this one must be this one because they're opposite. And this one here. And then let's give it a go. Let's see what is going on with this part. Hmm. No, I don't think so. I think this one must be the previous equations here. All right. So the previous equation, this one's good. And this one is less than that. This one is these. And because the CS, we define this one. CS is opposite. CS is, oh, you know what? I think I should define this one here. This one is 0 minus, oh yeah, yeah. This one is going to be nums of this one. Oh, this one is this actually. Yeah, I need to use this one all the time. Yes, I need to use this all the time. So, and then this one is x here, right? Okay, I have this one here. And oh, this one is good because I compare this one here. So this one is this. So now let's give it a go. Yeah, I should. Oh, wait a second. Yeah, I guess now it makes more sense because that's one. Let's give it a go. Well, still, this one is here. So I put this one here and maybe let me have this one here. I think I need to use this one outside because it is my original formula here. So yeah, makes sense. I need to use that all the way. Okay, so that's why uh, it didn't work previously. So the logic is still good. It's still on the right track. It just again sometimes you need to trim and adjust the variables locations here. So now we still have a little problem. So time limit exceed, right? Okay. So in terms of that, okay, what do we need to do is I think we need to trim it a little bit here. So it is basically while left is less than R, okay, and in the meanwhile, so because as you can see, so for these, there are some redundant data, so therefore we needed to check if they are the same. So left plus one, and then right here we have the left here. If this is true, we need to push left pointer. We need to push the left pointer, keep pushing it, right? Okay, keep pushing it. And for these, I see that we have and here. So this one, the ThreeSum. Let's see what is going on here. While loop. Oh, it's out, it left. Okay, go, and then let's give it a go. There we go. Hmm. There are still some things we need to optimize it. So for these, okay, let's see. What if I have another, let's see that. So, this is, let me have a while loop here. So while L is less than R and the nums of R is equivalent to nums of R minus one. Okay, let's see if we need to trim both sides, right? So because if there are adjacent similar data, I guess we need to just well get rid of. It seems like we still have something here. Let's see that. So from here, okay, so did I? Oh, I think I sorted, right? I sorted. Okay, I sorted, and the nums here, and the result is here. And for the rest, I think what if there are some continue? Maybe. Let's see. Okay, so we have this one. Oh, what if am I allowed it to round these at the beginning? So that simply will, okay, still the same. Oh, this wouldn't affect the rest. Okay. And if this is true, I guess right here, what do we actually need here? Okay, this one, is there any way we can optimize this from these one to from this almost the full square to full square? So let's see these. So R minus one and this one and that. Um, let's see. So when do we actually push these? So this is a must, no matter how we have to. And this one is this. So this one will first trim it. And this one, okay. I think we have to do this here, otherwise it doesn't make too much sense. And if we do this here, let's see. What if we do this here? Okay, cut it and paste it. And let's see. What if we want this program to pre-trim the data here? But I don't think maybe because if we do that here, we would miss the something here, right? So it doesn't make any sense. So therefore, we still put this one here. And I think probably before we add everything, oh yeah, we do need to trim it because the pre-trim is better than the later trim here. So if that is not in, so that gives me another thought is probably so we wanted to add something here. So because the Python is a bit slower, so we need to add more to we need to add more to optimize it. So this is so more trick to optimize it. So the C++ code here. So we have set here. So basically right here we sort. Oh, this one is not a full sort. I don't think this one is basically the the simulation problem, the simulations here. So it will also exceed this one here. And so the Python, I think probably we need to add a little algorithm here. So let's see. Okay, if I is bigger than 0, and what? Oh, we can pre-trim it, right? So if num of I is equivalent to nums of -1. Okay, that is true. Continue. Yeah, hopefully it makes sense because we pre-trim this one, but I guess we also need to pre-trim it in the previous layer. It still have this little step here. Let's see, the time exceeded. Let's see that. So and this one, oh, let's see. So if this one, I equals this, I equals I minus 1 here. If that is true, and oh, should I have a while this one, while this one? Oh no, if it's a while, oh no, this one is supposed to be if, right? So I will be increment, and this one will be checking it. Nums sort. Okay, I think I sorted right. So let me print nums here, just in case. Sometimes Leetcode platform is not working fine. So let's see. Okay, I do have this one. This one should be okay. Let's see. Still 2 cases. So let me copy. Oh, you know what? Maybe. Okay. So I have a while loop here. So return is in the same level here. And this one append. Hmm. If this one is not in, so okay, if inner is not in, if inner is not in res, and res appended that, so we also have a sort. Maybe this one is redundant. Do we need this one actually? Let's give it a go. Still okay. But the good news is we can get rid of these. Okay. Standout is okay. Yeah, standout is these. And this one is time out of limit here. We remove that sort so that would okay. If we remove that, that simply means we reduce the time complexity a little bit. So because the hidden one, there's still two annoying cases here. And not in that. We do need this one, otherwise there would be redundant. Or maybe no. For this, I doubt. But since we sorted and removed the redundant, for this one, yeah, then it makes sense because we already get rid of all the unexpected data, right? So for that, duplicate check, roughly speaking, is unnecessary. So we just don't use it, right? That's good. Okay. So, and then this is going to be a full score. Yes. There we go. So as you can see, you don't want to memorize the solution. If you memorize solution, it wouldn't work. You got to use your logical thinking to push it forward. So even though I solved this problem years ago, right? I treat every question as a new question because I want to train my I want to keep training my logical thinking. Um, Otherwise, I mean, simply just memorize the solution. No, it doesn't work. And yeah, this is one thing that's very important. And you got to know when and how to add and remove a certain line of code. And that's very important. As you can see, it's probably around 20 minutes. 20 minutes to solve a Leetcode medium level questions. And in terms of the user code rate, okay, so I guess 1 hour is very reasonable, right? Okay. And as you can see, I keep talking, right? I keep talking, and but when I stop talking is when I really getting closer to the official or to the right solutions, right? Okay. So which is somewhere here. So if you watch the video later, you'll be seeing, okay, so at this point, I stopped talking because I was in a deep mind thought, right? Okay. So because I finished all of my talking and all of my logical thinking, that's sufficiently to support my overall programming skill, right? Performance here. So later I just need to, this one is pretty suspicious, right? I need to delete it because it's just because it's too much, right? It's too much weight. I need to get rid of it, right? So and then I can jump, I can fly, right? Okay, that's something here. Hopefully it makes sense. Hello, Alex. Does it make sense to you?
Yeah.
Okay, good. So do not memorize solutions, all right? So you want to treat every new and old question as a new questions. Okay, here we go.